Hi, I'm Mr. Bennett and welcome to Stage 1 Physics. I'm doing an introduction to waves in this video. First question I'd like to basically ask you is, can a sound wave kill you? I've got a quick video that I'd like you to just watch and we'll go through the presentation after that. Awesome video. If you haven't checked out Indiana Jones and the Crystal Skull, you should certainly watch it. It's a great video. Alright, so if we start looking at what we're going to go through in this presentation today is we've got waves, energy through vibrations and also oscillations. Alright, so then we'll be looking at some terms that make up a wave, which are things called wavelengths. We've got our wave period. Our wave period and our frequency are inverses of each other, right? So, and if we divide our wavelength by our wave period, then that will give us the speed of the wave, and that will be in meters per second. All right, so that's essentially what we're going to go through. Obviously, the amplitude of the wave is the distance from the center line or the rest position of the wave to the crest and to the bottom of the wave, which is called the trough. All right, and then we've got our wavelength. Which is the distance from one part of the wave to the same part of the wave down there. Right, so oscillations. Now oscillations can be caused by a number of different things. So we'll definitely play around with some tuning forks. Alright, so they send out a compression wave or a longitudinal wave. Obviously, if you play with a slinky, you can actually generate different types of waves using a slinky, so you get a chance to do that. A string instrument, and here we've only got one string, but certainly when you pluck the string it vibrates and causes a sound wave. And obviously when we start looking at tubes, right, different types of wind instruments, there's obviously a whole range of those, but a trumpet's an example of one of those particular devices that set up a standing wave in a tube. So if we just look at our wave itself, we've got the amplitude. So the high points of the wave are called the crest, the bottom parts are called the troughs. The term amplitude relates to halfway from the wave to the top, to the crest to the trough. And obviously the wavelength is any point from the crest to the crest, or the trough to the trough, or that point in the wave to that point in the wave. Right? So it's the distance for one complete full wave. In other words, for the wave to reproduce itself. Alright, so the wavelength is the distance from the top of the crest to the top of the next one. It's simply the distance between successive identical parts of the wave is a really good way of remembering that. Now, frequency is the vibrations that are caused by the wave itself. So it's a number of vibrations that you get in a unit of time. So what we would generally say with the frequency, it's a number of back-to-back, back and forth vibrations that you get every second. Alright, so frequency will be measured in a term called Hertz. So 1 cycle per second is 1 Hertz, 2 cycles per second is 2 Hertz. We will measure Hertz in kilohertz, megahertz and gigahertz. Now they are just terms, so obviously a kilo is 1,000, mega is 1,000,000 and giga is 1,000,000,000 hertz. Right? So there'll be definitions or subtitles that you actually see. So when we start looking at an example of that would be a radio frequency. So if we've got an AM station at 960 kilohertz, well, that means that the electrons vibrate 960,000 times every second to produce that sound. When we go to an FM station, 155.5 megahertz, triple J, that vibrates 155 million times every second. So those electrons inside the antenna to produce that particular radio frequency, they vibrate that many times a second, which is quite amazing when you think about it. Alright, so the relationship between period and frequency, right, they are inverses of each other. So if you know one of them, you know the other one. We measure period in terms of the time to complete one wave, where the frequency is the number of waves that are completed per second. So here's an example. Have a frequency of 10 Hertz, then that would have a period of 0.1 second. Have 100 Hertz, then that would be equal to 100th of a second. And if you have a period of 20 seconds, then that would be 0.105 Hertz. Right, so they're inverses of each other. As I said before, if you know one of them, you will know the other one. So wave motion. So most waves are very useful for us. So to get information from a wave, so we get sound energy that travels to our ears in the form of a wave. Light travels in the form of electromagnetic radiation or electromagnetic wave, and that goes to our eyes. And then we have other types of waves, that electromagnetic waves in terms of telecommunications. So that's for radio and TV. Right, so if we have our wave speed, so we have a wavelength of 1 meter, and we have 1 wave per second passing a pole, then the speed of that wave would be 1 meters per second. Now, in this video, I hope you actually understood and learnt about vibrations produce waves. Hopefully you learnt about the wavelength, the period of the wave, the frequency, the speed, and the amplitude of the wave in this video.